will bring in brain sciences in the future. So as the director of this center, I think that my main challenge is to keep this interdisciplinarity. Probably human nature is that people like to be with people of their own kind. So physicists like to be physicists, and philosophers next to philosophers, and biologists next to biologists. And it's our great mission to work against these forces and to bring the physicists to talk to the biologists and the psychologists to talk to the physicists. And this is something that we are working hard to get. And again, it's not true interdisciplinarity is a big mission that we strive to be, and that we continuously work to get there. One of the ways that we achieve interdisciplinarity is through our teaching program. Ron mentioned it. One of the gems of this place is our PhD program. It's an international PhD program that we're very proud of. We have about 110 graduates to date, and our statistics are fantastic. About 40% of our graduates are professors in academia and leaders in the industry. This is just a few examples, also in Israel and around the world. These four are just a few examples in Israel and abroad. As I mentioned, the program is international. It's taught in English, and around 10% of our students come from abroad. It's an excellence program, so we admit students with very high grades, and there's a range. Some years we can't get more than 5 or 6 students per class. The last 2 years have been extremely successful, and we have about 18 students, out of which 2 or 3 are from abroad. Our faculty, to date we are about 34 faculty. Again, this is the full range from the new recruits, which are here on the right, to emeriti professors. So there are 34 laboratories. Not all of them are in this building. To date, we have about 50% of the researchers in the building, which is not fully occupied, and I will mention it in our tour. 2 years ago, we moved into our new home, the Goodman building, which is a unique building. I think nobody will disagree with that. It's a beautiful building, and I will take you around, so I won't mention it too much here. Just it was designed by Lord Norman Foster. It's his first building in Israel, and if you know Norman Foster's building, each and every one has a unique feature. The unique feature here is this facade around the building itself, which depicts the cells of the cortex. So these are actually inspired by drawing of the genius, the Spanish genius Ramon y Cajal from 1905, which was the first to draw the cells of the brain. And each of every one of these white cells is actually unique, like each of and every neuron in our brain is unique, and each and every one of you is unique because of the uniqueness of the neurons. Last but not least, I think it's appropriate to say that like many other researchers and projects like Oron mentioned, we're tightly collaborating, both on an individual basis, with bilateral agreements between the grants, between countries. There are many of these, and many of our researchers have individual connections, but we also, as a center, we have agreements between this brain center and other brain centers in the world. Currently, there are 4 active centers. A new one is going to start next week. So these have to do with the countries in Europe and in the US, and these centers, we're very proud of them, and they cherish international collaborations. International students and scholars are visiting here and we also go abroad. So this is very successful. And this is my last slide. We were born officially in 2009. We're celebrating 10, celebrated 10 this year. We are looking forward to our bat mitzvah next year and into stormy adolescent years to come. So thank you, and I'll see you in the tour, and I want to invite Mona Sorek.
Okay, welcome everyone. I'm really nervous. I have not been in a real conference since I came back from New York in March. So this is really great. And what I would like to talk about is genetic changes for overcoming stress reactions. And I'd like to talk about that in the focus of the family of genes that we study. This little pink thing is a gene, actually, and we call them microRNAs because they're very small. And we look at stress as something that we copied from physics. If you have a body and you apply a pressure, too much pressure, that body will break. And the corona event is a stressful thing, and what we need to find out is how to avoid breakage. And it's our brain that helps us in doing that. And I'd like to put through an evolutionary theory. We are all equipped to overcome stressful experiences thanks to the genes that we inherited from the wild man in the desert. And a lot of generations have combated stress just using the same machinery, except that the wild man in the desert was stressed when they ran away from a lion. They had to hide in a cave for 2 months. We get stressed from totally different reasons. And still we have the same machinery. So what we need to do is to adapt. And the microRNA genes help us to adapt. So this is one of my LSEC students, Shahar Barbash, who's now at the Rockefeller University in New York. And he looked at the evolution of microRNA genes, which are a very peculiar family of genes. They don't do anything, they stop other genes from doing their job. So they work like traffic marks. And 1/3 of these genes are unique to people. So we don't have them in mice, for example, which is an issue. And a lot of them correlate with one chemical compound that sends messages from our brain to the body, acetylcholine, which is the focus of much of our research. So let me give you a couple of examples. In 1997, the Japanese TV has shown one part of the Pokemon series, which everyone in the world knows about, except that that particular little movie had 5 seconds of rapidly flashing lights. And humans are very sensitive to that. That night, about 900 Japanese kids were hospitalized because of epileptic seizures. And that raised in our mind 3 questions. First, what happened? Why did those kids get sick? Second, how come the other 20 million Japanese kids didn't get sick? What protected their brain? 7 hours is very short for genes to function. So we said that must be a microRNA because they are small, they are smart, they don't do anything, they just block others. So Uriah Beckenstein, a PhD student in the lab, engineered a mouse where he could test that. And what he found was one microRNA that indeed can protect the brain from getting into epilepsy when we are exposed to rapidly flashing lights. Okay, this is important because that particular microRNA goes up in the Alzheimer brain. And about 20% of Alzheimer's disease patients suffer epilepsy, which no one knows where it comes from and how to treat it. So this is one example. So this is Mor Hanan, another graduate of our lab who's now working on a coronavirus project in a little company in Israel. And she showed one microRNA, they all have numbers, no names, that blocks stressful reactions in nerve cells. So this is interesting for many reasons, because that particular microRNA blocks communication by acetylcholine. So we like it a lot. What happens in the Alzheimer brain is that this particular microRNA goes down. So you could say the Alzheimer's disease reflects incapacity to control stressful conditions. And I'm sad to say that I've seen that happening to several people. We can test that in the blood, which is important, and it reflects what happens in the brain. So microRNAs contribute to our mental well-being. And that happens in different ways in men and women, which is a new topic that we are studying now. And women are more susceptible to Alzheimer's disease. They deteriorate faster when they get sick, and nobody knows yet why is that. Okay. So what about the links between mental stress and metabolic stress? A student in my lab, this is Geula Hanin, she just graduated and moved to Cambridge, UK, where she is a Newton Fellow. Looked at the parallel between metabolic needs and psychological stress. And what she found out is that the old cartoon, remember, the fat man is always unhappy and the thin man is always very happy. And she said that is connected to microRNAs, because when we get the microRNA 132 associated with stress, high levels, we also accumulate fat in the liver. So there is a network between the brain and the body, and stressful reactions are not very good for us. A lot of people who sat in isolation last 2 months complain about gaining weight. There we are. Okay, so we designed an agent that blocks this microRNA, which is handled by Yisum, the company that Rehem Sari was talking about. Hopefully we'll have a drug. Now, Israel is the world center of stress responses. We are always stressed. So we ran a study asking what are the long-term consequences of stress. And what we did was to look at a cohort of 18,000 healthy individuals who go annually for a routine checkup. And we convinced them to fill up a questionnaire saying, to what extent do you fear, for example, terror attacks affecting your daily life? And so on. And we looked at one parameter that the Chinese knew for thousands of years, checking one's pulse, which is a very simple test, but we do know that if the rate of pulse goes up consistently, that person would be at risk of stroke or heart attack or death. So what we've done was to use machine learning to look at these 18,000 individuals and ask who of those consecutively experienced increases of their pulse over 4 years. And we found a section of that community that did do that. And those were the ones who answered 5 out of 5 on their fear of a terror attack. So stress goes together with health risks for the immune system. So if you ever measure your pulse, we are all adults, so if it goes up consistently, go to your family clinician. There are medications to handle that. But volunteers who fear terror attacks are also more vulnerable to other health issues. Okay. So are there people who are more or less susceptible to stress? That's the other part of Geula's PhD, and she looked at genetic changes that block microRNA's activities in the brain. And she found one change in one of these genes, which goes together with elevated levels of blood activities, so there is a problem with the neurotransmission, elevated blood pressure, risk for stroke again, and that mutation was very high up in African tribes, and it's very low in northern, in Caucasian non-Jews. Here in Israel, we are in between, we are 17%. So if you ever doubted the population migration theory, humans came from Africa through the Middle East to the West. Now, what does that mean? Oh, sorry. Okay. So what does that mean in our evolutionary theory? Maybe that mutation was protecting people from stress, which helped the wild men in the desert to survive stress. So how do you test that? In Israeli soldiers, which are definitely stressed over time. So we collaborated with psychiatric experts from Tel Aviv University. We recruited 69 paramedics from the Israel Defense Force. We predicted that they might be subjected to trauma. So if they would be post-trauma patients, they would have elevated activities in deep brain nuclei and reduced activities in their frontal lobe. What we did was to expose these volunteers to a section of Silence of the Lambs. It's really unpleasant. And indeed, the carriers of the mutation showed elevated deep brain nuclei. However, they also showed even more elevated frontal lobe activity, which can help them block this stressful response. So our brain, just like the yogis from India proved 5,000 years ago, can learn to block stressful reactions. And that might be a lesson for development of better technologies without using any drugs. So in Israel, we also have ex-war prisoners who came back from Syria and Egypt in '73. And they are checked for post-trauma reactions every 3 years. And we recruited about 100 of those. This is Nimrod Madrer, that's his PhD project. And those people, 74 of them came back with post-trauma stress, not surprising. The amazing thing is that the others came back apparently healthy. And when we genotype them, we find that they carry a dual level of that mutation, so maybe it can protect people. Perhaps we'll be able to find out who is more or less sensitive. And I'd like to end by showing you what we do now, which is indeed in mice. This is Nadav Yayon, who just completed his PhD at ELSEC. And what he did was to create an algorithm that enables us to map the entire network of the acetylcholine communicating nerve cells in the mouse brain. So now we can expose a mouse to stress and find out what happens to each of these neurons individually and to the network in general. Okay, and of course, as usual, I get the honor to talk to you, but the thanks are due to the people who did the work, to the sources of support. So that was an ERC project that I talked to you about. And I'd like to cite Margaret Atwood, who said that this is not perfect. But if I wanted to reach perfection, she said, I would never write a word. So we keep writing. We collaborate with the colleagues overseas and in Israel. And I talked to you about timelines, the acetylcholine network, and the population impact of stressful reactions. And thank you very much for listening.
Well, thank you all. To conclude this part of the visit, I want to call on my co-host, the Chief of Protocol, for some concluding remarks. Meron, please.
Thank you, Yossi. It's very nice to be a co-host, especially in such a beautiful place, and as an ex-student of the Hebrew University, both first and second degrees, I am always happy to come back to this wonderful place. First and foremost, as some of the ambassadors and diplomats have said here, it's wonderful that you've managed to get us out and see each other, not on Zoom, but actually physically, and I really am enjoying the ability to speak to all of you personally as well, and thank you very much. For those of you who recognized Professor Shagrir from somebody in the ministry, especially the Asian ministers, of course he is the Chagai Shagrir's brother. So just in case you recognize both the face and the accent, by the way, I think you have a relatively similar one. So that is also a connection. Being with Yossi Gal on the same podium is always a pleasure. He was one of my mentors in the foreign ministry, and it's always been a pleasure to be with him. I think I learned a lot from him, and especially that he could do things also with a smile. That's something that I particularly enjoyed about it. He was a tough boss, but he knew how to smile at you. Once again, I don't want to take up more of your time. I do want to thank the Hebrew University for this initiative. I hope that it will be the beginning of many more. I'm very glad and thankful that we have had so many illustrious people here on the stage. I don't know about brain degradation, but I think mine has definitely taken a turn for the worse over the last few months at being holed up in my one-room department. So yes, it does have an effect, I presume, and especially worrying about all the other things that one is not managing to do at the same time. But once again, thank you very much. I do hope that you do find lots of answers to the billions of questions that exist. And once again, thank you, everybody, and have a wonderful tour. Thank you.
Well, Professor Shagrir is not only Hagai's brother, but the name Shagrir means ambassador, as some of you know. So once again, thank you very much. Now, on your way out, there are bracelets up there. So please pick up your favorite color. You will be divided into 4 groups because of the health regulations, and you will be led through some of the labs to actually see what the scientists are doing. Thank you very much, and we'll see you later.
After you take a bracelet, I suggest that we meet at the first floor, at the balcony of the first floor. So go into the building and walk on the stairs, the external stairs, and we meet there for the tour.
כן, תודה.